Hello everyone. Are you able to hear me? Please let me know if you can. You should be able to hear me. Hello. Good evening, Pawan. So we will be starting the class in a minute. It's great. Thank you. Please switch off the video. Please do not switch on the video. Please keep it switched off. Thank you. Please switch off the video, everyone. Onomitro Preeti Kumbhakar, can you switch off the video? Please switch off the video. Okay, thank you. Please switch off the video. Okay. It's pretty weird. Okay, so this class is being broadcasted in YouTube and also in everyone, please switch off the video. People are weird. Okay. Okay, thank you everyone for joining. We will be starting with a session on parity of odd and even numbers. So this is one of the most interesting topics in mathematics itself. So I hope you will enjoy it a lot. Let me see if we can move through this. Okay, that's great. So I'll remove this banner just to make sure that this is okay. Let's make it minimal. All right. So great. So assuming that everyone can hear me, let us start talking about this topic of parity of odd and even numbers. So if you are starting now, please switch off your video. This is a workshop on a maths Olympiad that is coming up in the month of July. It's the Bose Maths Olympiad. So you can always find it. You should be able to register it using the link in the that's in your ticker. So I can just put it in large maybe. Yeah. So using the link in the ticker, this is chinta.com/Bose, you should be able to register for this. And if you are interested in learning about Math Olympiad and if you are interested to get training for it, you should be able to also go to chinta.com's Math Olympiad program and register there. The Math Olympiad itself, that is Bose Maths Olympiad, the registration for it is free, but the main classes are of course paid. Okay. All right. So today we will be discussing a very beautiful idea from Math Olympiads, and that is parity of numbers. So what is the real meaning of parity? It's very simple actually. It's just odd and evenness of numbers. Please switch off the video, Shubhashri. Please switch off the video. Okay. So just odd and evenness of numbers. So let's start with an example. This is a very simple problem. All of you should be able to do it, but I'll tell you nevertheless, just to give a taste of what it means of a number, of parity of a number. Shomili Kundu, please switch off the video. This is weird. Please switch off the video. Okay. Suppose there are 22 integers and their product is 1. There are 22 integers and their product is 1. Show that the sum of these 22 integers cannot be 0. Show that the sum of these 22 integers cannot be 0. But let me tell you, this is not always true. For example, if I use a different set of numbers, so instead of 22, if there are, let's say, 4 integers, instead of 22, if there are 4 integers whose product is 1, so you are allowing positive and negative numbers. You are allowing positive and negative numbers. So if their product is 1, then the numbers should be themselves be either positive 1 or negative 1. Ranbir Roy, please switch off the video. Okay. So we have positive ones and negative ones, and only then the product can be 1. Otherwise, the product cannot be 1. How can the only way product of several integers can be 1? The only way the product of several integers can be 1 if they are themselves either 1 or minus 1. So here is a question. Suppose there are 4 integers and you want their product to be 1. There are 4 integers and you want their product to be 1. How is that possible? How can we have the product of 4 integers to be 1? Give it a try. So it is only possible in 2 ways. The product of 4 integers can be 1 only in 2 ways. What are the 2 ways in which the product of the 4 integers can be 1? Think about it. There are only 2 ways in which the product of 4 integers can be 1. Yes. So you can type down the solution in either Zoom or Facebook chat or YouTube chat. That's fine. You can just put in the answers there. So one way to do this is all 4 of them are positive ones. So first way, maybe I can write that. First way is this. All of them are positive ones. So you have 1 times 1 times 1 times 1, that's equal to 1. Okay. Ramesh Patel and Manisha Mahato, please switch off the video. Okay. So that's one way to do it. And as Sameer Chaudhary is rightly pointing out in the chat, that the other way to do it is you can have, let me use this. You can have +1 and you can have 2 +1s and you can have 2 -1s. You can have 2 +1s and you can have 2 -1s. So these are the only 2 ways this is possible. These are the only 2 ways this is possible. Okay. So I think this person is not understanding my point. So maybe you can just switch off. Okay, thank you. Goodbye. Okay, so these are the only two ways this is possible. You have plus ones and you have minus ones. And the first way is you multiply all of them. Okay, all of them could be negative ones. That's true, actually. So three ways. So negative ones, all of them. Correct. So that's actually true. I skipped that particular part. So three ways. One, all of them negative ones, all of them positive ones. And the other case is that only two of them negative one and only two of them positive one. That's correct. Okay, now the question is, what is the sum of the numbers? What is the sum of the numbers that you are dealing with now? Anvi Jain, please switch off the video. In the case of all of them are negative ones, when all of them are negative ones, so maybe I can write it here. When all of them are negative ones, so negative 1 plus negative 1 plus negative 1 plus negative 1, when all of them are negative ones, their sum is negative 4. Well, when all of them are positive ones, so positive 1 plus positive 1 plus positive 1 plus positive 1, their sum of them is 4. Okay. Now, if three of them is negative 1 and three of them is positive 1, so negative, or two of them is negative 1 and two of them is positive 1, their sum is 0. So this is the third case, is the case in which we are actually interested in. We want sum of the numbers to be 0. We want sum of the numbers to be 0. The numbers themselves, correct, exactly. So Samir Chaudhary is saying that the sum of the numbers is 0 only if there is a symmetry. Yes, correct. Very nice. So the question is now that if there are 22 integers, so for 4 integers whose product is 1, it is possible, it may not always happen, but it is possible that sum of all of them is 0, right? So if the 4 numbers are precisely negative 1, positive 1, positive 1, only then this is possible. Now the product of the numbers is 0. Sum of product of the numbers is 1, but the sum of the numbers is 0. For the case of 22 integers, is that possible? So we are getting some answers in Zoom. Let's see if we can get some more answers. So how do you start with this problem? Well, you start by observing that if you want the sum to be 0, if you want the sum to be 0, in that case, you need to have equal number of positive ones and negative ones. The only way the sum can be 0 if the number of positive ones and the number of negative ones are equal. So maybe I can clean up the screen a little bit and let's write this. So we want number of positive 1 should be equal to number of negative 1. That's the only way the sum can be 0. Now there are 22 integers. So there should be 11 of them should be positive 1 and 11 of them should be negative 1. That's the only way the sum can become 0. The only way the sum can become 0. Okay, now, is their product positive 1? If there are negative 11 negative ones and if there are 11 positive ones, what is their product? What is their product? Well, as many of you rightly pointed out in Zoom as well, that this is plus 1 times plus 1. So you have odd number of negative ones. You have odd number of negative ones. If you multiply odd number of negative ones, the output will be negative 1. So in short, this is not possible. You cannot have 22 integers whose product is positive 1 and their sum is 0. So number of negative ones should be even. Number of negative ones should be even. So this is just a taste of how oddness and evenness can be used to solve beautiful problems in mathematics. Okay. So let's go into a more interesting problem, a real problem in some sense. So let's see. So this is the so-called grasshopper problem. It's a very beautiful problem. You should first think about it very carefully. All of these problems are such that you cannot solve it directly by just plugging in a formula. There is no magic formula to solve them. That's why they are Olympiad level problems. You need to think very deeply about what's going on. Okay, so let's look at this problem. A grasshopper is jumping along a line. Please switch off the video, everyone. Please switch off the video. Okay, so a grasshopper is jumping along a line. So there is a line like this, and the grasshopper is jumping along the line. Maybe something like this. Okay. His first jump takes him 1 centimeter. Now remember, it can go left or it could go right. It's not necessary that it will always go left, or it is not necessary that it will always go right. So in the first jump, it will go 1 centimeter. It can go either right or it could go either or left. So the direction, which direction the grasshopper will go, depends on the grasshopper. We let it choose. Okay. The next thing is that in the second jump, it takes him 2 centimeters. So in jump one, it goes 1 centimeter. In jump 2, it goes 2 centimeters. Can anyone tell me how many centimeters it will go in jump 11? In jump 11, how many centimeters will the grasshopper move? In the first, okay, I'm getting answers now. In the first jump, it is going 1 centimeter. In the second jump, it is going 2 centimeter. In the third jump, it will go 3 centimeter and so on. So in the 11th jump, how far will the grasshopper move? Okay, I'm getting answers, very nice answers in Zoom. Excellent. So at each step, it is actually jumping that many times. At each step, it is jumping that many times. Very good. So at 11th step, it will go 11 centimeters. At 12th step, it will go 12 centimeters and so on. Okay, very good. Now, the real question is, suppose it has jumped 1985 times. Suppose the grasshopper has jumped 1985 times. Remember, you do not have control whether it is jumping right or left. It can do anything. But you know that it has jumped 1985 times. Okay? Can it return to its starting position? Can the grasshopper come back to its starting position? So jumping left and right, whatever configuration it wants to jump, it can do that. It's allowed to jump left and right at whatever order it wants. The question is, can it come back to its original position after 1985 jumps. Okay, so I'll show you a special case. I'll show you what happens when the grasshopper jumps 3 times. When the grasshopper jumps 3 times, it can actually come back to its original position. See, so suppose the grasshopper is starting at 0. This is the starting position of the grasshopper. It's starting at the point 0. So here you go. It's sitting here, right here. It's like a bird. You can think of it like a bird. So in the first step, it goes 1 centimeter to the right. So in the first step, it goes 1 centimeter to the right. In the second step, the grasshopper goes 2 centimeters to the right. In the second step, it goes 2 centimeters to the right. Of course, in step 2, it goes 2 centimeters. Shivgat, please switch off the video. Okay, thank you. So in the first step, it goes 1 centimeter to the right. It's in the second step, it goes 2 centimeters to the right. What happens in the third step? What should it do in the third step so that it can come back to its original position? What happens what could it do in the third step so that it can come back to its original position? Aha. So many of you are realizing this, that it can just go 3 centimeters to the left. It can just go 3 centimeters to the left. So in the final step, in the third step, remember, the grasshopper can go in any direction that it chooses. It can go right or it can go left. That's okay. But in the nth step, it must go n centimeters. So in 3, if the number of steps is equal to 3, then the grasshopper can come back to its original position. So some of you have observed that the grasshopper can come back if the sum of the say. Okay, this is weird. Shivgat, please switch off the video. Okay, thank you. So the grasshopper can come back if the number of steps is 3. That's great. Now the question is, if the number of steps is 1985, so maybe I can change the color of the pen. 1985. Can the grasshopper come back to its original position? Can the grasshopper come back to its original position? So this is the main question that we want to answer today. And some of you have rightly said that if you add the numbers from 1 to 1985, so this is the main idea. If you add the numbers from 1, 2, 3 up to 1985, this will be odd. Of course, you can try to add it and you can see that it's odd. And for some reason, the oddness of this sum will ensure that it cannot come back to its original position. But we want to really understand, why would that be true? Why would just adding the numbers from 1 to 1985 being odd will guarantee that the grasshopper cannot come back to its original position? So those of you are joining now, I'll ask you to go to chinta.com/Bose. So you can simply go to your browser and plug in chinta.com/Bose, and you'll be able to access the uh, registration page of the Bose Maths Olympiad, which is coming up in July. So this is the first workshop for that, the Bose Maths Olympiad. So if you're a student and you just want to access the Math Olympiad, you can use the student register for that. You can also go to Academy and click on Math Olympiad and other programs to access the actual classroom programs. Of course, the Math Olympiad contest does not have any registration fee, but you can register for the actual course uh, using this link for Math Olympiad. So that's something to keep in mind, that this is a workshop for this particular contest. So the contest is coming up in July. There will be several other workshops on it. You can also attend the actual course to do this. Okay. So now let's come back to the problem that we were doing. So the question is, how can we say that after 1985 moves, it cannot come back to its original position? So this is a kind of a tricky but intuitive idea that we will be using. So you see, suppose we write it like this. Suppose let's experiment with 5. Let's experiment with 5 steps. And we will see if we can come back to its original position after 5. So original position is 0. This is the starting position, right? This is the starting position. So what you do is you do like this. So for 3 it was possible. So what did you do? You did 1 plus 2 minus 3. 1 plus 2 minus 3. Shubhranil Pramanik, please switch off the video. Okay, it doesn't understand. Maybe we can switch it off from here. Okay. Great. So for the case of 3 steps, we could come back to the original position because 1 plus 2 minus 3 was equal to 0. Now the question is, after 5 steps, can it come back to its original position? After 5 steps, can it come back to its original position? So this is 1, 2, 3, 4, 5. You want this to be equal to 0, and you want to throw in pluses and minuses in between. You want to throw in the pluses and minuses in between. Okay. So this session will be over in the next 6 minutes. So let's try to finish this problem off in 6 minutes. Let's see if we can do it. Okay. So we want to plug in pluses and minuses in between. How do we do it? Well, just assume that there is a minus somewhere, there is a plus somewhere. Just randomly plug in pluses and minuses. We want to know whether this thing can be 0. We don't know whether this thing can be 0 or not. So the first observation, and the most important observation I would say, is something kind of silly. The right hand side is 0. The right hand side, this is 0, which is an even number. the right hand side is an even number. Now you don't really think about 0 that much maybe, but any number that is divisible by 2 is an even number, and 0 is definitely divisible by 2. So the right hand side is even. Remember, we are learning parity and we are using evenness and oddness. We are using evenness and oddness to solve this problem. So the right hand side is even. What about the left hand side? Can the left hand side, is the left hand side even or odd? So here is a strategy that we will take. Rijita Nandi, please switch off the video. Silly. There's no way to just switch off the video automatically for everyone. Okay. Now, what we will do is we will convert every negative sign to a positive sign. So here is the strategy. Convert negative signs to positive signs. How would you do it? How would you convert negative signs to positive signs? So what we will do is we look at the negative 3. Notice the negative 3. We will add 2 times negative 3 to the left hand side. We will add 2 times negative 3 to the left hand side. And we will add 2 times positive 3 to the left hand side. Right? If you add 2 times negative 3 to the left hand side, then you have negative 3 plus 2 times negative 3 will give you a positive 3. This gives you a positive 3. So if you add 2 times negative 3 to the left hand side, you get a positive 3. So the negative 3 becomes a positive 3. To balance it out, since you added 2 times negative 3 to the left hand side, you should also add 2 times negative 3 to the right hand side. You should also add 2 times negative 3 to the right hand side. So is 2 times a number odd or even? What is 2 times a number? Is 2 times a number odd or even? It's even, right? So you are adding an even number. You are adding an even number to the right hand side. The right hand side was even. The right hand side was even, and you are adding another even number to it. The right hand side was even, you are adding another even number to it. So now tell me, is the right hand side now even or odd? Is the right hand side now even or odd? You started with an even number on the right hand side. You added an even number. Correct, excellent. It's still even, because even, maybe I can change the color of the link. So even plus even is still even. See, 0 was even, 2 times negative 3 is even, so the output is also even. The output is also even. So even plus even is always even, right? So like this, if you convert every negative symbol on the left hand side, so you have negative 5 here, you add 2 times negative 5. This negative 5 becomes converted into a positive 5. To balance it out, you again, so maybe I can just erase this a little bit. To balance it out, you add a 2 times negative 5 on the right hand side. And the right hand side still is an even number. So if you keep on converting a minus sign to a plus sign in the left hand side, your right hand side remains even number, remains like an even number. So at the end of this process, at the end of this process, what do we have? At the end of this process, can anyone tell me what we have on the left hand side? When we have converted all the negatives into the positives, what will we have in the left hand side? At the end of the process, where we have converted every negative into a positive, when we have converted every negative into a positive, what will we have on the left hand side? Well, we will have 1 plus 2 plus 3 plus 4 plus 5, because we have converted all the negatives into positives. And the right hand side was 0 plus 2 times something plus 2 times another thing. And so on. So the right hand side remains even, but the left hand side is 1 plus 2 plus 3 plus 4 plus 5, and you can check that this is 15. So this is odd, but this is impossible. The left hand side is even, the right hand side is odd. This cannot be equal. Odd cannot be equal to even. And so you're done. You see, that's the reason. And the same trick would work for 1985. So I will urge you to think about it for the case of 1985. I just gave you a demo for the case of 5. Okay. All right. So thank you for attending the session. We will be coming back next week with another workshop, training workshop. You should go to chinta.com/Bose to register for the Math Olympiad. That's coming up in July. It's an online Math Olympiad, so you can do it from your home. There are interesting prizes at the end of it. And you can also join the actual Math Olympiad program, which is also conducted by Chinta. You can go to chinta.com to find out more. Thank you for joining the class. I'll see you next time. Take care. Bye.